All right, everybody. So today we are going to be working on finding the inverse of nonlinear functions. So for this problem here, it's just find the inverse of f of x equals x squared when x is greater than or equal to 0, then graph the function and its inverse. So what we have here is a restriction on the domain. So this graph f of x equals x squared, the domain has to be greater than or equal to 0. If you want to know what the graph of that looks like, just think about if you're graphing this quadratic, remember you start at 0, 0, you follow the 1, 3, 5 method, so you go right one, up one. Now normally I would go left one, up one, but since my x is greater than or equal to 0 is a restriction on my domain, I can only go right one, up one, and then go right one, up 3, and then right one, up 5. And then this is what the graph looks like. Alright, and so that would be the original, the restriction on the domain. Now if we're going to find the inverse of this function, let's just think about how we did it before. So first we'll switch f of x out for y, and then if I was going to solve this for x, I can solve it here, or I can switch the x and the y first, which we'll do that. We'll switch the x and the y. And then I'll take the square root of both sides. Now, I notice I took the positive and negative square root, because that's what you're supposed to do when you take the square root of a variable squared, so that'll cancel out there. And I'll be left with y equals positive and negative square root of x. Now, something important to note here is that the domain for the original was restricted by x is greater than or equal to 0. So the domain had to be 0 and then all positive numbers. So that means the inverse would be that the range has to be 0 and all positive numbers. So the range in this case, for this one, is restricted to y is greater than or equal to 0, because that is the inverse of x is greater than or equal to 0, right? They switched. So that means that this negative sign does not need to be there, so we just have y equals the square root of x, and that is the inverse of f of x equals x squared when x is greater than or equal to 0. It would be y is equal to the square root of x, which makes sense because x can't be less than 0 in this case for here, so that still works there, and also there's now just a positive sign here. So if I go to graph this, I start at 0, 0, it's at 1, 1, and then it is at 4, 2, and it would then also be at 9, 3, and it's then graphed a smooth curve like this. Yeah, not too shabby. Alright, so that is the inverse of the graph, and they're both graphed there for you. Alright. So, you remember when we were talking about determining if a relation was a function, one of the things we could use is the vertical line test. So if we use the vertical line test, it would tell us if a relation is a function. Now the horizontal line test tells us whether the inverse of a function is also a function. So if you do a horizontal line, so remember horizontal line is like the horizon, so it looks like that, right? So if you draw one of these horizontal lines and you move it up and down on the graph, if it only touches the graph in one place, then the inverse will be a function. If it touches the graph in more than one place, it will not be a function. So for instance, if I had a parabola like this, well, a nicer parabola, but a parabola kind of like that, this would be a function, but it would fail the horizontal line test, which means that its inverse would not be a function. So, goes with this one, says consider the function f of x equals the square root of x plus 2. Determine whether the inverse of f is a function, then find the inverse. Alright, so let's think about how this graph looks, because we just spent some time graphing it. This looks like this, right? So that's what that kind of graph looks like. So if I had a horizontal line and I moved it up and down on this graph, would it touch the graph in more than one place at any time? Well, the answer would be no. So, to determine whether your inverse is a function, yes. It passes the horizontal line test. Now find the inverse. Okay? So, we have f of x equals the square root of x plus 2. So, in this case, we have y equals square root of x plus 2. We'll switch the x and the y. Now square both sides. And then we'll subtract 2 and get y equals x squared plus 2. So y equals x squared plus 2. Now, let's talk about the restrictions that this is going to have in order to become the inverse. So the range of this one, right, the smallest number of the range could be a 0. The range will never be negative. So that means that here, the domain can never be negative. So this is restricted by x has to be greater than or equal to 0, because this is restricted, the range is y is greater than or equal to 0. Alright, so that's why it's flip-flop there. Alright, so that's the inverse. Alright, so we have these three problems here. Why don't you give them a shot, pause the screen, when you're ready, press play and see what the answers are. Alright, so we have here f of x equals negative x squared, x is less than or equal to 0. So, again, first switch the x and the y. So we'll have x equals negative y squared. You're going to want to divide both sides by negative 1, or multiply both sides by negative 1. You get negative x equals y squared. And then when you take the square root of both sides here, remember it's going to become plus or minus. Now, it says here that for the domain has to be less than or equal to 0. So that means that the range has to be less than or equal to 0 here. So we're actually just going to have the negative square root of negative x equals y. Alright, so now it said to graph the original. The original would start out at 0, 0. The x has to be less than or equal to 0, so I go left 1, down 1, left 1, down 3, left 1, down 5. That's 5. Alright, and then if we were going to graph a new one, we can either, use our points here. We had 0, 0, so that's still going to be a point. Negative 1, negative 1 is still going to be a point. And then our next point became negative 2, negative 4. So I can go to negative 4, negative 2, and I'll just graph that. Alright, for number 10, so the first thing we'd want to do is replace f of x with y. Switch our x and y. Subtract 3. Divide by 4. And then we'll take the square root of both sides. Again, we're going to have the plus or minus square root of this. We'll deal here. But it says x is greater than or equal to 0, so that means y is going to be greater than or equal to 0, so it's just going to be the positive. going to be the positive of the square root of x minus 3 over 2. So the square root of x minus 3, over 2. Now that's going to be a tough one to graph, but if I graph the original, I know that it's going to be at 0, 3. And then go right 1 up 4. Not going to the left, of course. That's all I could fit on this graph here. But so I'll just note that I had 0, 3, and I had 1, 7. So 0, 3, I'll just go to 3, 0. And 1, 7 will just turn into 7, 1. And that's the other graph. Alright, and for down here, the inverse of f of x is the inverse of f of x equals the square root of 2x minus 1 function. Well, yes, it would be a function because, again, it's just going to be one of those types of graphs, so that would be a function. So what is the inverse? Well, first thing I'll do is I'll make this y. Switch the x and the y. Square both sides. Yes, add 1. And then divide by 2. Remember the restriction on this, the range would be y is greater than or equal to 0. So for this case, your domain would be x is greater than or equal to 0. If there was a negative sign in front of the radical sign, then the range of this one would be y is less than or equal to 0, and so then the domain of this one would be x is less than or equal to 0. But since there's no negative sign in front there, the domain stays like that. Alright, so good luck today on the BIM. If you have any questions, please attend the Open Meet or write it on the Google Doc. Have a good day.